New moons! This is Hippocamp. It's the smallest of the Neptunian moons at just a tiny 35 kilometers across and was discovered in 2013. Hang on, 2013? But I've seen headlines from February 2019 that say Hippocamp had just been discovered. You see, that's when Hippocamp had its name confirmed by the IAU, which was reported in the latest issue of Nature, which also details how the moon may have formed. Up until then, Hippocamp was just called S2004N1. 2004? But you just said it was discovered in 2013. It was! Look, let's just start from the beginning, okay? In 2013, Dr. Mark Showalter was studying Neptune's rings, using images from the Hubble telescope that were first taken in 2009. Whilst toying with a new technique that brought out the fainter details of these images, on a whim, he decided to check out the space beyond the rings to see if there was anything there. Lo and behold, there was a fairly obvious dot that appeared, and when he and his team pulled over an additional 150 photos, which were all taken by Hubble across several years, this dot kept appearing again and again. Before long, they could actually plot an orbital path for this little dot. Thus, a moon had been discovered. Now, it was given the title S2004N1 because the earliest photo the tiny moon appeared in was taken in 2004. Side note, Showalter and his team did look over the photos taken by Voyager 2 when it first visited Neptune in 1989. They applied the same technique to bring out the fainter details in the images, but they couldn't find the moon they had just discovered. When studying the orbit of Hippocamp, they found that it was very close to Proteus, the largest of the inner Neptunian moons, like really close. And if you take a look at Proteus, you'll notice this massive crater that takes up most of its surface. This crater is so big, it's even got its own name, Pharos. These two factors point to a clear origin for Hippocamp. It's thought there was a massive impact on Proteus, most likely from a comet. This created Pharos and threw up a ton of debris into space, which over time accreted into the tiny moon we call Hippocamp. This is quite a common method for creating moons, and in this case Hippocamp would be classed as a second generation moon, where Proteus would be the first generation. However, Proteus itself is thought to be a second generation moon. This is because the inner moons of Neptune have had an interesting yet violent past, one that I'll explain in more detail in a future video, but for now, here is a quick summary. As Neptune was being formed, several tiny rocky moons accreted out of the dust cloud that the planet came from. These moons were the first generation moons, and they orbited in a normal prograde fashion around Neptune's equator. Then along came Triton, an icy dwarf planet that's bigger, heavier, and denser than Pluto. Triton was somehow captured by Neptune and began to orbit in a retrograde direction much further out from the inner Neptunian moons. Today, Triton has a perfectly circular orbit, but that wasn't the case when it was first captured. As Triton's orbit went from highly eccentric to perfectly circular, it disturbed the orbits of these inner Neptunian moons, causing them to crash into each other or be ripped apart by tidal forces. This left a lot of dust and debris in Neptune's orbit, which, over time, formed new moons and the planetary rings we see today. These moons are the second generation moons, one of which being Proteus. Therefore, Hippocamp is quite likely to be a third generation moon, having been formed from a second generation moon, making it a truly unique addition, not just to the Neptunian family, but to the solar system as well. And now it finally has a name, Hippocamp, named after the hippocampus, a mythological half-horse, half-fish creature found in the undersea tales of Greek mythology and is often seen pulling Neptune's chariot. What I find really interesting about Hippocamp is that it sat undiscovered in Hubble's images for almost a decade, which begs the question, how many other moons are just sat there waiting to be found? Dr. Showalter's latest paper talks about the moon detection techniques in detail, and even includes the code they use to process the images. Link to the paper in the video description. All of the photos taken by Voyager, Hubble, New Horizons, basically anything, have all been made available to the public, which means that everyone has the opportunity to process these images and potentially find an undiscovered moon.